I want to talk about the power rule. For exponents. Now, the power rule is pretty cool, if I do say so myself. The power rule is what happens when you have a power, an exponent, and you raise it to another exponent. We just keep going deeper. So, for example, you might have 3 to the 4th squared. It's going to be a big number. That's fine. 3 to the 4th squared. Now, as always, there's multiple ways you can think about it, right? 3 to the 4th squared is just 3 to the 4th 2 times. So that's 3 to the 4th times 3 to the 4th. Now, if you remember, we have our friend, the multiplication rule, which states that if you have two numbers, right, the same bases with exponents, then you add the exponents together. So this would be equal to the 3 to the 4 plus 4, or 3 to the 8. Now, if you look at 3 to the 4 squared and 3 to the 8th, is there a pattern that you might notice? Well, let's maybe try one more. What if I had, let's use a variable, y to the negative 2 raised to the 3rd power, right? So you could say that's y to the negative 2 times y to the negative 2 times y to the negative 2, right? I have y to the negative 2 3 times. So that's y to the negative 2 plus negative 2 plus negative 2, or y to the negative 6. Now, is there a pattern that you see? Well, for the power rule, the pattern is that we take our first exponent, the exponent on the inside, and we multiply it by the exponent on the outside. So the power rule is if I have x to the m raised to the n power, that's equal to x to the m times n. Right? I have x to the m n times. I have this number on the inside this many times as I have the number on the outside. So that's the power rule. Now, what does that look like if I have a monomial, right? What if I have something like, what if I have something like this? 7x to the 4th squared. What would that be? Well, remember, this is just 7x to the 4th 2 times. So that would be 7x to the 4th times 7x to the 4th. And with the multiplication rule, I multiply my like terms, 7 times 7, and my other like terms, x to the 4th times x to the 4th. 7 times 7 is 49. X to the 4th times x to the 4th is 4 plus 4, or x to the 8th. Let's try one more example. What if I had a 6, b 10 to the 4th? What would that look like? Well, again, you could put it as a to the 6 times b to the 10th times a 6 b 10 times a to the 6 b to the 10th times a to the 6 b to the 10th. Okay, that's a lot of writing, but that's okay. I have a to the 6 times a to the 6 times a to the 6th times a to the 6th times b to the 10 times b to the 10 times b to the 10 times b to the 10th power Okay, 6 plus 6 plus 6 plus 6 is a to the 24. 10 plus 10 plus 10 plus 10 is b to the 40th power. And that would be your answer. Okay, this is all well and good, but can I do this an easier way? Surely. Do you notice a pattern? Well, maybe you did. I have here, this is 7 squared is 49. X to the 4th squared is x to the 8th. A to the 6th to the 4th, 6 times 4 is 24. 10 times 4 is 40 for b to the 40th. So instead of writing all of this out, you can just multiply each exponent by whatever exponent you have on the outside. So if I had, I don't know, x to the m times y to the n, and all of that was raised to the, we'll do p. That would equal x to the mp, right? M times p times y to the np, n times p. So that's how it works for monomials. Hope that was helpful. See you in the next video.